Okay, we will start our lesson today by making a revision first for the rules or the identities, the basic trig identities, before we start completing problems. Okay, and this is the last session for the lesson for the second lesson. Okay, for the unit 10. Okay, let's start together. This is a basic trig identities. We have a quotient identity. It's a very important. If we have any problem containing tan or cotan, you must change tan to sine over cosine and cotan cosine over sine. So the first thing, if we have any problem to simplify tan or cotan, you must get sine over cosine here and here cosine over sine. You must relate any problem to sine and cosine, sine and cosine. And also the reciprocal identities. The reciprocal identities, the reciprocal of sine, it's sec, and cosine, it's sec, and tan, it's cotan. Okay, so also if we have sec, cosec, or cotan, we can change them into the three main trig functions, which are sine, cosine, or tan. Okay, the Pythagorean identities. This is what Abdullah asked for yesterday. Yesterday, Abdullah asked about them. We have here three main Pythagorean identities, which are sine squared theta plus cosine squared theta is equal to 1. And from this, we can deduce another two rules. If we need to find sine square, get cosine in the other side by the opposite sign. So sine square equal 1 minus cosine square. If we need to find cosine square, get sine square in the other side by the opposite sign, or by subtracting sine square from both sides. And we get cosine square theta is equal to 1 minus sine square theta. Also, we have here tan square theta plus 1 equals 6 square theta. So 6 square theta equal tan square plus 1, and cosec square theta equal cotan plus 1. Okay, pay attention about this very well. The co-function identities. The co-function, it means if we have two complementary angles. Two complementary angles, it means their sum equal 90 degree. So if we have two angles, their sum is 90 degree. So the value of the sine is equal to the value of the cosine.
Assalamu alaikum.
And for example, sine 30 equal cosine 60, and sine 20 equal cosine 70, and so on. Okay, also for tan and cotan. Okay, the last identity, negative angle identity. If we have a negative angle for the trig ratio sine, it turns the value of the sine to negative. Okay, so if you have negative angle and you get the value of sine for this angle, the result will be negative. The result will be negative. For cosine, the result is positive because cosine eats the negative sign. Okay, because cosine in the first and in the last, which is the fourth quad, is positive, so it eats or removes the negative sign. For tan, also like sine theta, if we have tan negative theta, it will be negative tan theta. It means if you have a negative angle, you need to find the tan of this angle, the result will be negative. Okay, this for the identities, I make a revision for them. So the main idea, if we have any problem, please relate any problem to sine and cosine. So we must relate any trig ratio to sine and cosine. If we have cosec, I change it into 1 over sine. Sec, 1 over cosine. Cotan, 1 over tan. If you have tan, sine over cosine, and so on. Okay? Okay. Let's complete. This is the first example. 6 square, sec theta over sine theta cotan theta. It's equal to, I need first to make like this. Okay, let's start. I have 8 students now, so I start with Khalid Al-Manif. Khalid. Khalid? Okay, Nasser?
Yes, Mister.
Okay, Nasser, I need to solve this problem or choose a correct answer.
Okay. Um, just
Yes, Mister.
Uh,
بدري.
okay, Khalid, wait, Khalid, you can solve the next
لا لا
example.
عادي، انا اقول خالد يحلها وانا اللي بعدها.
Okay, there is no problem, Nasser.
لا
Okay,
لا
Khalid.
لا.
Khalid,
Yes.
we have here sec theta over sine theta cotan theta. Its simplest
Yes.
form will be tan theta, tan square theta, or sec square theta, or cosine square theta.
We first have to transform sec and cotan to the main trigonometric functions.
Okay, so we make a fraction like this. Okay, sec
Yes.
it means
Sec is cosine's inverse. So
cosine inverse. So 1 over cosine. So
1 over cosine
yes, instead of sec, I write 1 and write
over
down cosine. So this
yes.
is a transformation of sec. And I complete. Then I have here sine
Sine as it is.
as it is. So I write here sine theta. And what
Yes.
about
Cotan, we inverse it, so it will be tan over
what about cotan? Can you give me the value of cotan first? Cotan, it means what over what?
cosine over sine.
Cosine, we can write it as cosine over sine. And then if we need to simplify, you can simplify now. You can simplify, Khalid, by removing what?
We bring sine up.
Or yes, or you can remove it with this sign.
Yes.
Sine with sine directly. Okay, so the remainder will be a fraction that
So
contains
it will.
one up and down.
It's C, Mister. Sec square.
Yes, because
Cosine theta and cosine
cosine,
theta.
yes, cosine is cosine theta, and here cosine theta is remainder.
Theta and
Cosine times cosine equal cosine
squared
square
theta, but
theta.
we don't have it down, so we have to flip it and make it sec squared theta.
Yes, it's the reciprocal of 6 square theta. So 6 square theta is the result, as Khal said, which is letter C. Which is letter C. Okay, so the result is letter C. So as Khalid start the problem, we have sec. We change sec into 1 over cosine. So where is sec? This is the sec of this angle. Okay, I change from sec to its reciprocal, which is 1 over cosine. And then sine theta as it is, and cotan as cosine over sine. I cancel sine with sine up and down because they are multiplied here. Okay, cancel. The remainder is 1 over cosine multiplied by cosine. Cosine times cosine equal cosine square. So 1 over cosine square is 6 square. So this is the answer of the first problem. This is the answer of the first problem. Okay. We'll go to the next example. We'll go to the next example. Just 10 seconds if you need to write. This is the last session about this lesson, verifying trigonometric identities. Okay. Okay. Let's complete another problem. Here we have some complicated problems or long problems. Substitute one or more basic trig identities to simplify the expression. Okay, factor or multiply if necessary or as necessary. You may have to multiply both the numerator and the denominator by the same trig expression. For example, you may multiply down and up by sine, down and up by cosine, and so on to cancel one with one to get a common denominator we will see in the problems. write each side in the identity in the terms of sine and cosine only. So the main trig functions that we use to solve this type of identities is sine and cosine. So we need to relate sec, cosec, cotan to sine and cosine. Then simplify each side as much as possible. The properties of equality don't apply to identity as with equations. Don't perform operations to the quantity in each side of uninvariant identity. It means if the identity equal to 1, for example, equal to cosine, so you have a big or complicated side equal to cosine. And I said verify. So we can't use this as equation. Okay, it's equal to 1. So I can turn in the other side by the opposite sign and so on like this. Okay, so we don't use the identity, or we don't deal with the identity as an equation. Okay, let's start a problem. Let's start a problem to see. Okay, so we have here verify cosec theta plus sec theta equal to 1 plus cotan theta over cosine theta is an identity. I need to find, I need to verify it's an identity. It means the left hand side equal to the right hand side. The left hand side equal to the right hand side. Let's start to work. Okay, together I'm going to Hussein.
Yes, Mr.
Okay, what shall we do, Hussein? We have the right hand side and the left hand side. What shall we start?
With the right one.
With the right one. Okay, the most complicated. What shall we do in the right one?
The 1 plus cotan theta. I don't think there's a relation. So we have to flip or to replace cotan theta by cosine over sine.
Pay attention with me, Hussein. Here you have cosec at the beginning, cosec, and here sec. I said relate each trig ratio into sine and cosine. So we can relate them to sine and cosine. What about cosec first?
Cosec equals 1 over sine.
1 over sine. So here sine theta down, and here 1. And what about sec?
1 over cosine.
And 1 over cosine. This is the first step to know what we shall do in the next side. First, I need to add. You have a common denominator?
No.
So we need to make a common denominator. Our common denominator will be?
Sine theta times cosine theta.
So sine cosine. So sine theta cosine theta. And up?
Sine theta plus cosine theta.
So it's sine or cosine theta plus sine theta. There is no problem, it's commutative. So we have here, this is the simplest form. What in the left hand side. I'm going to the right hand side. In the right hand side, as you see, you have what here?
Cotan and
down.
cosine. Down cosine.
Okay. I need this denominator to be like this denominator. Here cosine and here cosine. Cosine here is multiplied by what?
Sine.
So I multiply up and down by cosine and turning cotan to its value. So here I make 2 steps. The 2 steps are, first, I multiply here by sine theta and here by sine theta. And multiply, which is 1 plus what? Cotan, it means what over what?
Cosine over sine.
Cosine theta over sine theta. Okay, Hussein. Now, okay, you have the same denominator. I can remove the denominators now.
Okay.
The
Cancel
remainder will
them.
be cosine theta
Sine
plus
theta.
sine
Cosine
theta. So here cosine plus sine. In the other side, make distributive property. Distribute here, multiply, and here multiply. The result will be
sine theta
yes
plus cosine
Excellent.
theta.
So the left hand side equal to the right hand side. You get here sine theta times 1 equals sine theta, and the sine theta times cosine over sine theta. So you remove sine with sine, the remainder is cosine. So the left hand side equal to the right hand side. So our answer will be by a good handwriting, okay, like this. We have here, this is our original equation. The first step, he changed cosec into sine and sec into cosine. So 1 over sine plus 1 over cosine equal the same side in the other side. And then after that, he make a common denominator and get cosine plus sine over sine times cosine equal sine up and sine down. As we make, we multiply the right hand side by sine theta up and down. After that, this side as it is, and here he enter by sine distributive property, becomes a sine plus cosine, and here sine plus cosine. You can remove this by this, or it's equal to 1, and here it's the result. Okay, I can return back to get. Okay. So this is the answer of the problem. This is the answer of the problem. You will find, inshallah, the video on SBS if you need to revise what we said on the session. Okay, I'm going to this problem. I'm going to this problem. It's a multiple choice. Determine whether sine theta plus cosine theta is equal to 1 plus tan over sec theta. Okay, so yes, 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 or no. It's not identity. It's not equal. Okay, or yes, and this is the answer. The second is the answer. The third is the answer. We will see together. Okay, we have here Khalid. Khalid, we have here Nasser. Are you ready now? Nasser,
Hello.
are you ready now?
Inshallah.
Okay. First, it's an identity or no?
We
will
need to
see.
solve, to
We will
try.
see.
Yes.
We will see. We'll try to solve it. In the left-hand side, it's simplest form, sine plus cosine. We can
Yes.
simplify. Okay. We're going to the right-hand side. What shall we do to the right-hand side to know it's equal to sine plus cosine or not equal?
You can open tan, make it sine over cosine.
So the first step here, here 1 plus 10, it means 1, and here sine over cosine theta, yes. And then
The secant, do we make it one of the basic trigonometric functions or not?
yes,
Okay. So flip.
it will be
The secant, make it
1
1
over,
over, yes.
1
Cosine,
over
I think.
1 over cosine, yes, because S always with C. So if you have sec, it's cosine, cosec, it's sine. Okay.
Yes.
Now we have, I can write this by another side. So this is the right-hand side by 1 plus sine over cosine
Times cosine theta. So multiply will no.
Okay, so we have here cosine theta and here multiplied by cosine as you said. Multiplied by cosine as you said. Okay. Okay. What shall I do after that?
So it will be cancel cosine by cosine.
I cancel cosine by cosine. No, it's wrong.
Why?
Because you have plus here.
Ah, okay, okay, yes.
Can't cancel. So before you cancel, I need here to remove this plus or get a common denominator between 1 and this fraction. If we have a common denominator, we can cancel. Okay, so it's a common mistake if you cancel here and here, cosine with cosine, because we have here plus. So to finish this problem, I just take cosine as a common factor between 1 and sine over cosine. So take cosine as a
Yes.
common factor. 1 becomes what?
One plus sine
No.
theta.
One,
Oh,
this
one times. Wait, yes,
I
yes.
change it into cosine over cosine. So this one, I change it into cosine over
okay.
cosine. Okay. So if you change one to cosine over cosine, it means cosine over cosine plus sine over cosine. We have a common denominator. I take the common denominator as cosine, and up will be.
So it will be sine plus cosine.
Yes, sine plus cosine or cosine plus sine. So now you can
Cancel.
cancel. Okay, multiplied by cosine. Now you can cancel up with down. So cancel here and cancel here. The remainder will be cosine plus sine. It's like the
Yes.
left hand side. So the result will be
Yes, it's an identity.
yes, letter
Okay.
A. Letter A,
yes.
because as you see, we have
Before we
cosine
cancel,
plus
yes.
sine over cosine times cosine. You cancel cosine by cosine. The remainder will be cosine plus sine as the second side. Okay, so it's letter A. Okay, I can leave the problem for 20 seconds to write the answer. Okay, let's complete another example. Let's complete another example. Okay, simplify 1 minus sine squared plus, times 1 plus sine theta, 1 minus sine theta using the trig identities. Okay, I can start with Khalid.
Okay, so
Khalid, what shall I do to solve
1
this?
minus sine, which will be equal to cosine.
No, 1 minus sine squared.
I think
1 minus
that
sine.
we should change it to cosine.
Hmm.
1 minus sine squared is equal to
1 minus
cosine
sine
squared.
squared, 1 minus sine. So we can't change this or this. Khalid, if we have, I give you a hint. If you have x minus y and in the other bracket x plus y, what is the result?
Perfect square.
Not perfect. This is difference of two squares. It will be
X
squared minus y squared. That's right.
y squared.
That's
So
right.
the same. Yes.
So here we use
1 squared.
yes. So
Yes.
this is a difference of two squares. This is a difference of two squares. If you have two brackets, the two brackets are the same, but the middle sign is different. Okay, so it means difference of two squares. So x squared minus y squared, we can expand it into x minus y multiply x plus y. So as the same, we use this rule here. So the result will be Khalid. Khalid?
It will be 1 minus sine squared.
Yes, 1 squared, which equal to 1
1 minus sine squared.
yes, sine squared theta. 1 squared is equal to 1. So the result will
Equal
be
to
1
cosine.
minus sine square theta, which equal to what?
Equal cosine squared.
Yes, so this
Cosine
is
square.
equal to cosine square theta, which is letter B. Okay,
B.
so I can return back. Okay, so it's letter B. So we have here the problem. Khalid start the problem, okay, by getting 1 minus sine equal cosine. It's wrong. 1 minus sine squared. So I need this sine to be squared. Okay, what shall I do? We have another bracket. The two brackets are the same but different in the middle sign. If you have two same bracket in the middle sign, it means it's a difference of two squares. So the first squared will be 1, the second squared will be sine squared. So now we have cosine square as you said at the beginning. So the answer is cosine square theta. I'm going to Musa. Musa.
Yes, Mister.
Okay, Musa. We will try to solve together the next example. Okay, simplify the expression. Sine theta plus cosine theta all squared minus 2 sine theta over cosec theta. What shall I do? Can you give me a hint?
First, the squared.
We need to finish this first. Okay, I need to finish this. This is called a perfect square. The perfect square, we expand it as
Sine theta. Then plus and minus, right?
no. This is a bracket all squared, not the square here and the square here. It's a big difference. If we go back to the problem, the previous one. Okay, here, if we go to this one, okay, we have here two brackets. The two brackets are the same but different sign. So we get the result as 1 squared minus sine squared. It means the first number power 2 minus the second number power 2. But here, in this problem, okay, in this problem, we have plus between them and always power 2. So it's a perfect square. How we can expand the perfect square? I'll write you the hint. We have here x plus y all power 2. It's equal to the first squared. It means x squared. The second squared and always positive, which means y squared. How we can get the middle term? The middle term is we take the middle sign first, it's a plus. First times second times 2. It means x times y times 2. It means 2xy. So this is the expand of the bracket always power 2 or a perfect square. Yalla. Can you expand this by the same way?
Okay, so Sine theta squared.
So sine square theta. Okay.
Plus 2 times sine times cosine
Yes, 2 sine cosine.
plus cosine squared.
Excellent. 2 sine cosine plus cosine square theta. Okay. This is the bracket. Okay, this bracket, yes, minus 2 cosine theta over cosec theta. Thanks, Musa. I'm going to Abdullah. I'm going to Abdullah. Abdullah Al-Eid. Abdullah, I think you have a problem with your mic. Okay. I'm going to Omar. 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 Okay. Omar. Rakan.
Yes, hello, Mister.
Okay. Rakan, I need to complete. Now, the first, the second, the third term are ready, but what about the fourth term? We have down cosec theta. What about cosec? Cosec, it means what?
Okay, one
The
moment.
reciprocal of what?
Cosec is 1 over sine.
Excellent. 1 over sine. So we change cosec to 1 over sine. So it's minus 2 cosine theta. And here, instead of cosec, I write 1 over sine. For the rules, this sign is going up. This sign is going up because it's divided by 1 over sine. It means multiplied by sine. So the result will be 2
cosine theta.
Yes, cosine theta sine.
Sine.
Yes, excellent. So pay attention now. I just drop this. Now I'll drop the bracket. So I have here sine square theta plus 2 cosine sine or sine cosine. It's multiplied, no problem about the order. Plus cosine squared. Can you cancel? Yes.
Yes.
This and this. One of them is positive and the other is negative, and they are like terms, so I can cancel 2 cosine sine with negative 2 cosine sine. So the remainder will be
Sine power 2 plus cosine power 2.
okay. Sine power 2 plus cosine power 2 equals to what? Sine square theta plus cosine square theta is equal to
Equal 1.
excellent, is equal to 1, and this is the first Pythagorean identity. Sine square plus cosine square equal to 1, so the result is letter D. The result is letter D. So again from the beginning, the last two problem is related to two basic rules in algebra, which are difference of two squares and perfect square. In this problem, we have the perfect square. How we can expand the perfect square? We make the first power 2 plus or minus according to the middle sign. 2 times first times second, or twice the product of the first and the second, plus the second squared, By the same way, I write here the rule with sine theta plus cosine theta power 2. So I expand it, and here cosec as cancelled, we change it into 1 over sine, and turn it up or simplify it, cancel. The remainder is sine square theta plus cosine square theta, which equal to 1. Okay. So this is the end of our lesson, but we have, as I said at the beginning, I have a sheet. This sheet is a revision sheet for the 2 lessons together. It's like or the system of the exam. Okay, so I'll now try to show you the sheet. Okay, so pay attention with me. This is a sheet. Okay, I can only get a new shirt, and this is your sheet. Okay, so please download this sheet from SBS. You'll find it on SBS. This sheet contains 16 problems. It's related to the 2 lessons together. Okay, so the last problem only is a problem